Hello everyone, my name is Octavio Percivaldi. I am a student at the UNC FAMAF University in Argentina, and today I'm going to give you a little introduction to my thesis work. As you can see from the title, I have been working on implementing a new distributed database for delayed tolerant networks. The good thing about this distributed database is that it is capable of automatically synchronizing data changes with its multiple instances spread over a D3TN network. This implementation is an npm package that can be installed and used on any JavaScript application that uses Mongoose as its database. But why will you need to use this database? So let's take this delayed tolerant application as an example. This application works in 3 different locations, separated by huge distances. Therefore, it is the perfect scenario to use a D3TN. Those 3 locations are the Earth, the Moon, and Mars. This example application will have at least 3 different backend instances up and running simultaneously all the time, which means there will also be at least 3 different databases separated from each other, 1 backend and 1 database per location. The problem with having these separate databases is that when a user creates, deletes, or modifies an existing file or data from one instance of a database, those changes will not affect the other 2 remaining instances. So, how do we solve this synchronization problem? This is where delayed tolerant Mongoose comes in handy. In summary, delayed tolerant Mongoose is a wrapper for Mongoose, which makes it work on delayed tolerant networks through the use of protocols such as micro D3TN, which are necessary to synchronize the different databases instances that you have in a distributed network, such as seen in the previous illustration. It is very easy to install, since it's enough to run npm install or yarn add to add it to your project, and it will almost be ready to use. This little graphic illustrates how delayed tolerant Mongoose works. When the backend needs to save or read information, it just has to make a normal connection to the database, as usual for any backend. The special thing about delayed tolerant Mongoose is that when saving information locally, it also sends update packages through the D3TN to update the rest of the non-local instances. This is done by using micro D3TN. So, what is micro D3TN? Micro D3TN is a stack of protocol implementations, which includes the implementation of the bundled protocol version 6 and 7, which are very important, since they are the ones used to send data in a D3TN. It also has an API that any application can connect to it through socket connections, and this is what delayed tolerant Mongoose takes advantage of in order to send and receive network update messages. Here are some short links that may be useful for you if you want to know more about micro D3TN. I will also leave them in the description of the video. Delayed tolerant Mongoose and Mongoose have some minor differences. The first difference is the small configuration object it needs in order to work, which must be configured before you start using its delayed tolerant functions, otherwise they may not work correctly. Here it is an example of the values that could be given to this object. Then, delayed tolerant Mongoose has its delayed tolerant methods. As you can see in this example, the create method can be replaced by the DT_create method, so that in addition of creating an entry locally, we also create it in all the other instances that we have configured in the initial configuration object. This doesn't just work for the create or update one method, but for every method that creates, edits, or deletes data from the database. Here it is a list of all available delayed tolerant methods in delayed tolerant Mongoose and its local counterpart. And finally, the last difference with respect to Mongoose is the data usage, but for that, it is necessary to explain the different data merging methods that delayed tolerant Mongoose currently has. The first algorithm is quite simple. The only thing it does is that, when creating the synchronization package, it adds the local creation or modification time. Then, when the package arrives at the rest of the instances, only the local modification dates are compared, and not the dates in which the documents arrive, since they are 2 different times. And it keeps the latest version, discarding the others completely. The second algorithm is more complex. This works exactly like Git when resolving conflicts between two branches in a PR. The two different versions of the file are compared using their lowest common ancestor, and all changes are merged into a single final document, which is shared all across the database. The downside of using this method of merging is its use of data on disk, since all versions of each database entry must be kept saved. This graph shows as an example the comparison of data usage between one method and another. Using the none method uses the exact same amount of memory as Mongoose, since no data is saved that Mongoose doesn't already save. To end this presentation, I am going to introduce the CAP theorem. It is a major topic of discussion when it comes to distributed systems and especially distributed databases. CAP stands for consistency, availability, and partition tolerance. By consistency, it means that the database should always return the most up-to-date value or an error. By availability, it means that the database should always return a value and never an error. That value may not be the most recent write. And by partition tolerance, it means that the database will continue to function, even when messages are delayed or dropped between different nodes of the network. The Tolerant Mongoose has both the availability and partition tolerance properties. It does not yet have the functionality to lock the network to ensure that the changes that are read will always be the last writes, in order to ensure consistency. But it will in the future, and it will be added as one more configuration in the initial configuration object. Although the synchronization problem can be solved individually for each application, this can be a problem since a specific solution must be thought for each application, and that's impractical. In addition, some difficult problems must be taken into account when creating a custom solution, such as multiple edition of the same database entry from two different locations. This is why a package like D3TN Mongoose is needed, or will be needed in the future when D3TN networks become mainstream. And while it's not perfect yet, it is on its way to be a good tool for JavaScript app developers. Some of the future works are the development of new data merging tools. Merging methods, savings in the data usage for the three-way merge strategy, new synchronization configurations, and ensuring consistency. So, this is the end of the introduction to the D3TN Mongoose. If you want to know more, I will leave the link to the repository in the description. If you have any questions that have not been answered in the video, or if you want to discuss a particular topic, you can leave a comment or send me an email to either of these two addresses, which will also be in the description. So, thanks for watching, and until next time.